Hey everybody. Today we're going to work through the practice test. This is in preparation for your test on Thursday over Chapter 4. So we will work through all of the problems on this practice test, and I would think that since it's called practice test, that it might be quite similar to the real thing. Hint. Number one, we're going to find the exact value for the cosine of 5 pi over 4 for the sine of the angle whose tangent is 4/3, for the angle whose sine is -1/2, the angle whose cosine is 0, and the cosecant of 3 pi over 2. I hope you were listening as I wrote those problems down, because as I wrote them down, I was saying what they were asking me to find. The cosine of 5 pi over 4, the sine of the angle whose tangent is 4/3, the angle whose sine is -1/2, the angle whose cosine is 0, and the cosecant of 3 pi over 2. So, first thing I'll do with this one is change that radian measure into degrees. 180 divided by 4 times 5 is 225. So I'm going to find the cosine of 225 degrees. So I will draw my circle, and I'll go around the circle. 225 degrees is down here. The reference angle is 45. I'll put a 1, and a √2, and pay close attention, these two are negative because we are in quadrant 3. The cosine is adjacent over hypotenuse. That would be -1 over √2 or -√2 over 2. Onward. This says I'm finding the sine of the angle whose tangent is 4/3. So I will draw a picture of this angle first. Oops. I got to be careful. This notation means I'm on the right half of the circle only. So I'm going to find the angle whose tangent is a positive 4/3, so it must be in quadrant 1. I have said a zillion times, probably to the point of boring you, imagine that if this number is positive, I don't care if it's tangent, sine, cosecant, doesn't make any difference. If that angle is if this number is positive, the angle is in quadrant 1. So the tangent is opposite over adjacent. So that means I've got a 4 and a 3 here. The Pythagorean theorem tells me that is 5. What do I want to know about that angle? I want to know the sine. The sine is 4/5, opposite over hypotenuse. The angle whose sine is -1/2. This time I am actually finding an angle. I am looking again on the right half because the inverse sine is a right half function. There's my negative number, which tells me I am not in quadrant 1. I am in quadrant 4. The sine is -1/2, so my triangle is labeled like that, and this is a 30-degree angle. Remember, you're only in the right half of the circle. You are not allowed to go over here. So in order to get this angle, we're going to have to go down, and the answer is -30 degrees. The angle whose cosine is 0. Again, we've got this inverse notation. This is a top half function. A top half function, inverse cosine. This is a 0. 1s and 0s are very special numbers, so we look for them on the circle itself. So given that these are the only part, this is the only part of the circle that's possible, where do we see a cosine value of 0? Remember, cosine is associated with x. The only place x is 0 is right there. So the answer is 90 degrees. Cosecant 3 pi over 2, first thing I'll do is change this guy into degrees. So pi is 180 divided by 2 is 90 times 3 is 270. 270 is a quadrantal angle. Much like this problem, I'm going to be looking around the circle. I know my angle is 270, so I'm looking right here. That point is 0, -1. X is 0, y is -1 if the radius is 1 for 270 degrees. I want the cosecant. Cosecant is reciprocal of sine. Sine is y over r, so cosecant would be r over y, which is 1 over -1 or -1. All right, good job with part 1, question 1. Now let's move on to number 2. We've got one of these big ugly equations, and we're going to determine if it is sinusoidal and what is its period. So we've done that before. So here we go. We have 8 cosine 3x minus 4 cosine 2x. And in order to answer both questions, we need to know what its period is. So we are going to look at the period of this, which would be 2 pi divided by 3, and the period of this, which would be 2 pi divided by 2, or pi. So we have the individual pieces of the function. The period of the first one is 2 pi over 3. That means it starts over again every 2 pi over 3. So 2 pi over 3, 4 pi over 3, 6 pi over 3, 8 pi over 3, and so on. This one starts over every whole pi. So pi, 2 pi, 3 pi, 4 pi, and so on. Now the first number in the list that matches is the winner. And right here you have a match. So this is not sinusoidal because these two numbers are different, but it is periodic and it has a period of 2 pi. So the answer to the question is 2 pi. Now we're going to do something very simple. We're going to change 2 radians into degrees. Do not make this hard. It's the very first thing we did in this chapter. Pi is to 180 as 2 is to x. That's it. Pi radians is 180 degrees, so 2 radians is how many degrees? Pi x equals 360. 360 divided by pi is the answer. Find a negative coterminal angle for negative pi over 7. All right, kids, coterminal angles. How do we find coterminal angles? We've talked about this a lot before Christmas mainly. To find coterminal angles, we add or subtract revolutions. If we're in degrees, that means we'll take our angle and we'll add 360 or we'll subtract 360. So if we had an angle of 10 degrees, coterminal angles for this one would be 10 plus 360 or 370, or 10 minus 360 or negative 350. Now there are zillions of other coterminal angles, but the way to find the easiest ones, simply add or subtract a revolution. Now, this angle is in radians. We're going to answer this question in radians. So we're not going to change it to degrees. We're going to do this smart. Since we're adding or subtracting revolutions, all we need to do is add or subtract 2 pi. 2 pi is a revolution. So I'm going to take this and either add 2 pi to it or subtract 2 pi to it. Now, this particular problem specified I want a negative answer. So this is what I'm going to do. I'm going to subtract. So I have negative pi over 7 minus 14 pi over 7. Now do not tell me where this came, do not ask where this came from. That would be embarrassing. I'm getting a common denominator. I am subtracting fractions. I do what I always do. I multiply top and bottom by 7 so that I have the same denominator. The answer to the question is negative 15 pi over 7. Negative 15 pi over over 7. Number 5 says I want the sine to be positive and I want the cosine to be negative. Which quadrant does that happen? Well, think about it now. Which quadrant do you have a positive sign? Remember, sine is associated with y. Y is positive up here. So the sine is positive up here. Greater than 0 means positive. Less than 0 means negative. So here is where the sine is positive. That's where y is positive. Now I need x to be negative because cosine is x over r. I need x, cosine x, to be negative. That happens here and here. So the only quadrant that has a positive sine and a negative cosine would be quadrant 2. So the answer to the question is quadrant 2. Number 6. Given the secant, find the values of the other functions. All right, we're all really good at this. This is pretty easy. Now, the part you have to pay attention to is they tell you which quadrant you're in. You are between 3 pi over 2 and 2 pi. That's quadrant 4. Remember, all the way around is 2 pi. This is half a pi. This is 1.5 pi's. So if we're between 1.5 and 2, we are in quadrant 4. And the secant is 5 halves. So I label the hypotenuse 5 and the adjacent 2. I'll do my Pythagorean theorem, and this works out to be negative root 21. How do I know that? I did my Pythagorean theorem. It's negative because I'm down there in quadrant 4. So I can fill in the blanks. Sine would be negative root 21 over 5, which means cosecant will be negative 5 over root 21, or negative 5 root 21 over 21. Cosine is 2/5. That was kind of a no-brainer since the secant was 5 halves. We could have done that. Tangent, negative root 21 over 2. So cotangent is negative 2 over root 21, or negative 2 root 21 over 21. This is, okay, a 3-part question, so let's get the picture drawn, and then let's go through it here. Okay, all right, so the first one, it tells me R is 8, so I'm going to go ahead. R is 8, theta is 100, and I want to find the arc length. I remember that arc length is radius times radians. Your life would be so much easier, groupies, if you'd remember that. Radius times radians. So the issue is that the central angle in problem A is given to me in degrees. So I am going to change that degree measure into a radian measure. Pi is to 180, as something is to 100. So that's 100 pi over 180. Might as well reduce that to 5 pi over 9. So the radian measure of my angle is 5 pi over 9. The radius is 8. 40 pi over 9, my unit is, I don't know. If this was 8 inches, this would be 40 pi over 9 inches. That's my arc length. It's that easy. Arc length is radius times radians. Keep it simple. B, find the area of the smaller sector. Okay, we want the area of the smaller sector. So the area of the whole circle would be 64 pi. How do I know that? Area is pi r squared. So the radius is 8, so pi r squared would be 64 pi. I don't want the whole area though, I want only a fractional piece of the area. What fractional piece do I want? I want 100 3/60ths of the area. So I'll cancel those out. I'll reduce that to, let's see, 5/18. So that's 5/18 times 64 pi over 1. Can I reduce any more? Because I don't have a calculator on this problem. Let's see, 2 goes into there 9, 2 goes into there 32. So 5 times 32 is 160 pi over 9. And if that were inches, this would be square inches. Now, we want the area of the larger sector, so that would be this. This was a smaller sector, but the larger one. So you have a choice. You can start over, completely start over, only instead of using 100, use 260. So you could do 260 3/60ths times 64 pi, and go ahead and simplify that. Or, since you already know the area of this one, you could take the whole area, which is 64 pi, and subtract 160 pi over 9. If you do it this way, then obviously you're going to need a common denominator. So you'll times this by 9. And 64 times 9, let's see, 576. So that's 576 pi, 576 pi over 9, minus 160 pi over 9. That would be 416 pi over 9. That should be the same thing you get if you do it this way after you get all of the reducing done. Okay, now we're going to sketch a couple of things. We're actually going to do 2 sketches here. So we're going to sketch . So we're going to sketch y equals, where am I? 2 cosine 1/2 x minus pi over 8. And we're going to make our usual list: amplitude, period, frequency, phase shift, and vertical shift. And I'll just fill those in as we go. Okay, so here we go. We got a cosine curve. It's a positive cosine curve with an amplitude of 2. It has a phase shift of positive pi over 8. So my cosine curve is going to start at positive pi over 8. Remember that a positive cosine starts and stops at the top of the hill. What is its period? Well, its period should be 2 pi. But we have messed that up by putting in 1/2 in there. So my period is going to be 2 pi divided by 1/2, which is 4 pi. That means that from beginning to end is 4 pi. So this label will be 4 pi plus pi over 8. I'm starting at pi over 8 and adding 4 pi. So I get myself a common denominator. That would be 32/8 plus 1/8. This label right here is 33 pi over 8. 1/8 pi plus 4 pi. 4 1/8. This is the midpoint of 1 and 33. The average of 1 and 33, 1 plus 33 is 34, divided by 2 is 17. 1 plus 17 is 18, divided by 2 is 9. And 17 plus 33 is 50, divided by 2 is 25. The frequency is 1 over 4 pi. Frequency is always 1 over period. We should never miss that. And there is no vertical shift on this problem because there is no number stuck on the end. If there were a number stuck on the end, whether it was plus or minus, I would either, well, if it were plus, I would take this picture and move it up 3 units. If it were minus, I would take this picture and drop it down 3 units. Nothing in terms of labeling or anything would change. Okay, now we are going to do a tangent picture. Haven't done a whole lot of these guys. Luckily, the tangents are easy. We remember that a normal tangent curve looks like this and has a period of pi, a normal tangent. This is not a normal tangent. This is a negative tangent with a number stuck in there. We know what that number does. That number divides the period. So the period should be pi, but our period is being divided by 5. So we have a tangent curve with no phase shift, so it's going to be situated on the origin just like tangent curves are, but its period is pi over 5. That means, now use your heads, from here to here, this is the origin right there, from here to here is pi over 5. So we have to go forward and backward the same amount to end up with a total of pi over 5. So this has to be pi over 10, and this has to be negative pi over 10. If you go a tenth forward and a tenth backward, you've gone a total of 2/10 or 1/5. This is a negative tangent, so it's turned upside down, so he looks like that. There is no vertical shift, there's no number added onto the end. That would take this point, lift it up or down. The frequency is 5 over pi, and as is the case with every curve except sine and cosine, every curve except sine and cosine, there is no amplitude. There is no height to this picture. It goes on forever and ever. Number 10, we got a picture and we're going to write the equations of it. So we're going to do what we just got done doing, only we're going to do it backwards. Okay, so we know how to do this. Here's my picture. Going from negative pi over 6, so we're going to write our equation. You get the idea. And I'm going to fill in the blanks. So it's either a sine curve or it's a cosine curve. Okay? So we're going to start filling in the blanks. It doesn't matter with which equation you start. It doesn't matter. Some people do them both at the same time. That would be fine too. Let's think of this. When I drew it just now, I started drawing here and I went up a hill and down a valley. So I immediately thought, oh, I have a sine curve. It's a sine curve with an amplitude of 4, a phase shift of negative pi over 6, no vertical shift because I'm not lifting it up or down at all. And there is some kind of number in here that I need to figure out because this period is not 2 pi. This period has been divided by something. How do I know that? Because I am going from negative 1/6 to positive 3/6. What is that? From negative 1/6 to positive 3/6 is a distance of 4/6. Not 2 pi. It's supposed to be 2 pi, but it's not. It's from negative 1 to positive 3. That's 4. 4/6. So 2 pi over n equals 4 pi over 6. So 12 pi equals 4 pi n equals 12 pi over 4 pi. This number must be 3. R period is 2 pi over 3. I wrote 4 pi over 6, but of course that's the same as 2 pi over 3. Now, if you think of this as a cosine curve, which you might have right from the beginning, you could start here and stop here. That period is still 4 pi over 6. The amplitude is still 4, and there still is no vertical shift. The only thing that you might have to reconsider, or that you will have to reconsider, is this number. Where is this curve starting? Voila, right where it's supposed to start. So there's no phase shift either. You can write these equations just like this, but since you'll probably be transferring them to an answer blank, you would transfer that first one as y equals 4 sine 3x plus pi over 6, no need for the 0 on the end. And this one would be 4 cosine 3x, no need for any of those zeros. Easy enough. Oh, now we're going to get our calculators out. Remember, this is called practice test, and I gave you a little hint that maybe it looks like the real test. We just did all of the no calculator problems. So now we're going to get page 2, and it is going to be some calculator problems. Let's see what we're doing. Answer this question in radians. This question says, find the angle whose tangent is 5/6. Could we answer that in degrees? Absolutely. The directions tell us, answer it in radians. So change your calculator to radians, type second tangent 5/6, and the answer is 0.695. I don't know what I'm supposed to round to, so I'll just round like that. Let's not sweat about that. Get that answer, that's all that's important. Now we're finding the sine of 12 pi over 7. Should I leave my calculator in radians? Absolutely. That's a radian measure. I have to input a radian measure. That's 12 pi over 17, sorry. That's a radian measure, so I'm going to input it in radian mode. So sine 12 pi divided by 17. The answer is 0.798. 0.798. 13 says solve this equation. All right, so we're going to do what we always do. What are the directions? Okay, the directions have me in degrees. So I think I'm going to go ahead and change my calculator right now to degrees, so I don't forget to do that in a minute, because this says solve between 0 and 360, which would mean I'm going to solve this equation in degrees. So here we go. Let's subtract 5 and divide by 2. So I need to find the angles that have a sine of 2/3. Now, note those directions. That means you have the entire circle as a window of opportunity for answers. Alrighty, so I'm going to go around the entire circle. Where will I look? I have the whole circle. Where will I look if the sine is 2/3? If the sine is a positive number, where will I look? Quadrant 1 and quadrant 2. Remember, sine is associated with y, and y is positive in quadrant 1 and quadrant 2. So the sine is 2/3. That is not one of my special triangles, so I'm going to go to my calculator since I'm allowed, and I'll type second sine 2/3. And I get 41.81. So the angle in degrees is 41.81. That angle is in quadrant 1 and quadrant 2. In quadrant 1, the answer would be 41.81. 41.81. In quadrant 2, what would the answer be? I hope you're saying 180 minus 41.81, because that's what it is. So 180 minus 41.81 gives me 138.19 degrees. So those are the two answers to the problem. And number 14, I got a couple problems up there at the top. The rest of all that is the answers. So hopefully, between the answer sheet written out and this video, you'll be figuring some of this out. A flying squirrel is in a tree 18 feet above the ground. Here's the squirrel 18 feet above the ground. His angle of depression to a nut on the ground is 27 degrees. How far is the squirrel from the nut? How far is the squirrel from the nut? Here's my angle. This is the opposite and the hypotenuse, so I will use the sine function. Sine 27 equals opposite over hypotenuse. X sine 27 equals 18, and x equals 18 over sine 27. I'm going to go ahead and figure out that answer. That is a degree measure, so make sure my calculator's in degrees. It is 18 divided by sine 27. He is 39.65, was that feet? I can't remember my units. Feet from, yeah, feet from the squirrel. The nut and the squirrel are 39.65 feet apart. All right, and then the very last problem on the practice test. We have a duck in the pond. Here's the duck. And he is looking at a hawk in the top of a tree at the edge of the pond. The duck is 100 feet from the base of the tree. Here's the base of the tree. Here's the duck. The duck is 100 feet from the base of the tree. The tree is 32 feet tall. What are we looking for? The angle of elevation. Notice it does not say the duck is 100 feet from the hawk. It says the duck is 100 feet from the base of the tree. So the function I will use, I have opposite and adjacent, so I'll say tan x equals 32 over 100. So x equals the angle whose tangent is 32 100ths. So I will go to my calculator, second tangent, 32 100ths. And that angle of elevation is 17.74 degrees. There you go. If any of that was confusing to you, ask your neighbor. Ask your neighbor. I'm sure that someone in the class can help you figure that out. Good work. Have a great day.